Hi there everyone, it's Mr. Robs.
I am Mrs. Lynn.
Right, and we are looking at parts of a circle today. Just to get a few definitions going on, we have a circle and we have a chord AB, which is this line that just connects one point of the circle to another point of the circle. This would be another chord, lots of chords. And this is an arc AB here, which is shown by this.
All right.
Okay, we have a segment, which is you have a chord in the shaded region here. That's called a segment of a circle.
Makes sense.
And then like the pie piece or the pizza piece with the curved edge here is called a sector. And that angle down here is referred to as the central angle. Okay, so let's work on finding arc length and area of a circle. Arc length first. Here's a problem first. We say we have a circle with center A and with BAC equal to 50 degrees and a radius of 5. We want to find the arc length of BC. So we want to find out how much is that curved part. Well, and with this angle's 50. Let's take a moment and pause and think about what this all means. Okay, I've got a sketch here, a geometry sketch pad, where I have angle CAB, this angle down here. And as I change C, the angle changes down below here you should be looking at. As I change my C value, the angle changes accordingly.
And obviously, the length of the arc is also going to change.
Exactly, and that's the blue one up here. This is referring to the blue length of that arc on the circle. So if I move that, the angle changes CAB, as does that blue length CB. Okay, so this angle now, CAB, is 83.75. I know the whole circle has a measurement of 360. And I'm going to do a quick calculation here. I'm going to calculate the angle, the central angle, CAB, and I'm going to divide it by 360.
So we compared part of the degrees of the circle to the whole circle.
Right, part to the whole. Now, the circumference is the entire length of the outside perimeter of the circle. If we do, that's comparable to 360. The length CBD, the blue, is comparable to this angle here, CAB. So let's do a proportion.
And we can do a part to whole proportion again. So part of the circumference, which is CD, divided by the whole circle circumference. And what do you know?
The ratios are the same. Even if I change the angle, the ratios change, but they're always the same value. And if we do, we can check. I know if two things are the same and they're divided by each other, it equals 1. And this equals 1. And if I always change this, two equal things are always 1. It stays the same.
Yeah.
So part to whole, just making proportions. So let's use that idea here. If I know I have 50 degrees as my part,
the whole would be 360. And since the ratios are equal to each other, we can set that equal to part of the circumference, which is BC.
Right, and I'll call it L for arc length, over, well, now we need the whole. That's circumference.
It's easy. It's 2 pi r, and our r is 5.
5. And so now I just have to cross multiply to solve this. I'm going to cancel out my zeros, make it easier on myself. So I have 5 times 10 pi equals 36L. I'm going to divide by 36, and I get 50 pi over 36 is that arc length.
Let's see if reduce that a little bit.
Let's see if I have a calculator. We'll just find the actual value of it itself. Where is my calculator?
Sometimes it'll ask you for the value in pi form. So
that's true. Okay, so if we want to find 50 divided by 36, and if I want to make that into a fraction, reduced terms, I get 25. There we go. So 25 over pi, or 25 pi over 18 is L, which is approximately to 3 significant figures, I can take that value and times it by pi. And I get
4.36.
4.36.
And
We don't have any units, so let's say it's centimeters, 5 centimeters, so this would be 4.36 centimeters. Okay, there's the idea. So, to generalize this formula, if I call this angle here theta, and I'm looking for the arc CB, which I'll call L, I take the angle part of the circle over the entire circle.
So part to whole.
Part to whole.
Equal to?
To L is the part of the length, the arc length. The whole is 2 pi r. Here is your formula to find arc length. Make it.
Hi there, it's Mrs. Flynn.
And Mr. Rops.
And we're here to continue with another example.
Right, given arc length L is 3 centimeters in our circle with a radius of 2 centimeters, calculate the central angle.
All right, so we know from before that if we look at part to whole, it's theta compared to 360 and
L the arc length over the circumference.
R. All we have to do is substitute in our values.
All right, so I'm looking for the central angle theta. So theta over 360 is going to be 3 over 2 pi times 2.
Easy enough. Cross multiply.
Yep.
360 times 3
is 720 plus. It's a big number I can't do in my head.
It's okay, we have a calculator.
Super.
So
Theta, 4 pi theta.
Thank you. And that's what we're solving for. So we can divide by 4 pi.
Divide by 4 pi. Well, I can do 360 divided by 4, though. I know that.
All right.
That's 90. And then 90 times 3 is 270 over pi. Well, that's a pretty funny looking angle, but that's what the value is.
All right, well, let's go figure out what it is.
Let's see what the approximate value is. So 270 divided by pi
equals
85.9 degrees.
3 significant figures.
There we go. Super.
That's it.